Hi, welcome to another lecture on business mathematics. Today we are going to take a look at some of the material we have covered so far. So this is going to be a review to get you ready for your upcoming exam. So first question, we're going to start with a problem in exponential equations. Suppose we have a problem stated as 1000 to power of 3x plus 1 is, say, 100 to power of 2x minus 3. We want to find x. So the way we approach this type of problems is to write both sides with the same base. So we notice that 1000 is 10 cubed and 100 is 10 squared. So the important thing is we are reducing everything to the same base. So this becomes 10 cubed to power of 3x plus 1, and this becomes 10 squared to power of 2x minus 3. So you remember, if I have a to power of m, the whole thing to power of n, I multiply all the new exponents. So this becomes 10 to the power of 3 times 3x plus 1 and this becomes 10 to the power of 2 times 2x minus 3. Now once the bases are the same, once these are the same, we can say the exponents have to be the same for the two sides to be equal. And to do that, we just need to simplify this. This becomes 9x plus 3, and on the other side I have 4x minus 6. I bring 4x on this side and take my 3 to the other side. So it becomes 5x is equal to minus 9. So x has to be minus 9/5. That's the x that makes both sides to be equal to each other. Okay, for the next question, we are going to have something from logarithm. So I have the following equation. Logarithm of x in base 64 is equal to 5, 6. Question, of course, is to find x. We remember the following. Logarithm of a in base b is equal to c. If and only if, this means if I take b, raise it to power of c, I should get the a back. So 64 raised to power of 64 to raise to power of 5, 6 has to be x. Now what does it mean to take a number, raise it to power of a fraction? You can do it two ways and they are the same. You can take the nth root of b and then raise it to power of m, or you can take b, raise it to power of m, and then take the nth root of it. Either way. So here I proceed like this: 64 to power of 1, 6, and then I'm going to raise it to power of 5. This is same as what that one is. So what we are attempting is to write our answer in the simplified form. This is, well, it's an answer, but it's not simplified. So I say 64 to power of 1, 6. That would be my radical. And then I remember 64 is 2 to the power of 6. So 6 root of that is 2. 2 to the power of 5 is going to be 32. So this problem was solved basically on our memory that we remember 64 is 2 to the power of 6. So 64 to the power of 1 6 itself is 2, and then we raise it to the power of 5, and here's our final answer. Let me box the final answer so that we get used to that habit. Next question. So picking questions from the exercise that you have. So the next question, similar to one of the problems you have, is 3 raised to the power of logarithm of x in base 2 is 27. We want to find out what x is. So first step is to write both sides in the same base. So instead of 27, I think about 3 cubed. So this exponent should match this exponent, and so logarithm of x in base 2 has to be 3. And just like the problem we did, 2 to the power of 3 is going to be x. X will be 2 to the power of 3 because we said logarithm of a in base b picking c is same as saying a is equal to b to power of c, and that is what we used in this case. So the next question is natural log of exponential of x is 5.37. We want to find x. Let me remind you of a basic rules of logarithm. If you have a logarithm in base b of b to power of x, that is simply x. That was one of the identities or one of the rules. Now if b is just e, logarithm in base e, this is abbreviated as natural logarithm ln, so we make it a lot easier. So this identity then is going to read like ln of e to the x. So this b and this b, these are just we're replacing them by e. This is simply x all by itself, meaning the left hand side is a way of skillfully packaging x in a way that looks complicated, but actually is just plain x. So the equation itself is already handing you the answer, and not much of anything needs to be done, and that is the solution in this case. The next question is another example of logarithm. Here we are asked to do the following. Logarithm of, say, 3x plus 7 is equal to 2. Again, let's remind ourselves, when we write logarithm in base b of a is equal to c, it simply means a is equal to b to power of c. These are same statements. So this is logarithm in base e. So same idea, logarithm of a being c. This means, well, remember that the base that is used here is just e, so there's really e here. So a is e to power of c. Whatever the base is, that has to be used. So 3x plus 2, 3x plus 7 will be e to power of 2. Okay, so whatever the base is in this case, when it is e, it's not written, but this base has to be raised to power of 2 to get you your 3x plus 7 back. Now you can go ahead and use your calculator to figure out what this thing is, or you can continue like this. I can subtract 7, so it becomes e squared minus 7, and then I can divide by 3, so x becomes e to power of 2 minus 7 over 3. This is referred to as the exact answer. Exact answer, its mathematical tradition is that whenever you can write it in exact form, that's what you try to do. If you want to get an approximate answer, you can apply at this stage, or you can do from the very beginning and track it to get your answer that way. So if you want to use your calculator at this stage to get your e squared turns out to be 7.39. Remember, e is 2.71828. However, your calculator has a button for exponential function by itself, so you might not need to memorize this, but in case you want to just type the numbers yourself, you can use that approximation. And then you can go ahead and continue these steps, and for x you get 0.1297 to 4 decimal places, and that gets us our x. Let's do another logarithm problem. Suppose I have 5 logarithm of x squared y cubed plus 2 logarithm of 1 over x squared minus 3 logarithm of y squared. These are all natural logarithms. What we want to do is to simplify, which means write with one logarithm only. So the question is, if you simplify this to logarithm of something, what is that thing? Well, let's review some basic rules of logarithm. We said if you have logarithm of a to power of n, that's same as n logarithm of a. We might have written it with some particular base. It doesn't matter what the base is, it's the same idea either way. So the exponent becomes a multiple up front. So this 5 is really an exponent of the argument of logarithm. So we have to write it logarithm of x squared y cubed to power of 5. This is logarithm of 1 over x squared to power of 2. And here, since the coefficient is negative, I can write it logarithm of y squared to power of minus 3. Another rule of logarithm we had is that if you have logarithm of a plus logarithm of b, that's same as logarithm of ab. So here I have several logarithms added up. I can write it as a single product. So I'll write it x squared y cubed to power of 5 times 1 over x squared squared. And the other one is going to be, I can write it as y to power of minus 6. Now we want to simplify as far as we can go, so I take the exponent inside. This becomes logarithm of x10 y15. This becomes x squared, squared becomes x to power of 4, that is here. Y to power of minus 6, I can write it in the denominator as y to power of 6. Now I simplify and I get logarithm of, we simplify 4 here, becomes 6, and the y becomes 15 minus 6 becomes 9. So this is our final answer, and we have simplified it as far as we could. Okay, for next question, let's see what other problems do we have on the review sheet. Okay, next question is related to differentiation. So we're going to have a few problems from remember our basic rule was that if you have a times x to power of n plus b times x to power of m and so on, and you want to differentiate this, it's a very simple rule: a n x to power of n minus 1, and then b m x to power of m minus 1. m and n could be any number. They don't have to be whole numbers. So for example, if you have radical x and you want to differentiate this, better thing to do is to write this as x to the power of 1/2, and to differentiate that you write it as 1/2 x. You have to lower this thing by 1, so 1/2 minus 1 becomes minus a half. If you want to simplify this thing, you can write it 1/2 x to the power of 1/2, and then you can simplify even further and write it 1/2 radical x. These are all different versions of the same idea. So here's a question: if I have f of x is equal to 14 7th root of x, what is f prime of x? So first we write this thing in the power notation. It becomes 7th root, means the exponent is 1/7, and the derivative, we multiply the exponent. So 14 times 1/7 times x to the power of 1/7 minus 1. Well, 14 times 1/7, that's 2. X to the power of, take a common denominator, 1 minus 7. So it becomes 2 times x to the power of minus 6, 7. You can write that in a number of ways. One is 2 over x to the power of 6/7. Here's another way. You can put the 7 as the root, and x to the power of 6 stays inside. So that was an example for differentiations. This is the simplified form of the derivative. Okay, we had some review problems, mostly related to mathematical functions, their properties. Let's have the rest of these questions in another video. Until then, good luck and God bless.